Alright, now we will define what vertical asymptote means. Let me first show you one example. It is given a rational function whose graph is given over there. Here, no matter how much you zoom out, you can see here this curve is actually this rational function. It's whenever this curve is getting closer and closer to somewhere around this location, the y values or this function is just getting smaller and smaller from the, and whenever we go closer and closer to that location from the right side, the curve is just getting larger and larger, right? So let's, if you want to look into what that location is, this look like at x equal to -2. So we have some interesting feature here. So the vertical asymptote is actually the line x equal to a is said to be the vertical asymptote for the graph of the function if f of x either increases or decreases without bound as x approaches a from either the left or the right. So that's exactly same situation we are having here, right? When like let's assume x equal to -2 is one of the straight line here. I can construct that if you want to look into the graph. So we have this function x, we have this line x equal to -2, this vertical line. But you can see here whenever we go closer and closer to that line from the left hand side, this function is just getting smaller and smaller, or it's decreasing without any bound, right? You can see here, if you zoom out, you can see it's just getting smaller and smaller. At the same time, whenever we go closer and closer to -2 or closer and closer to this straight line from the right hand side, the curve is just getting larger and larger. So either, I mean, it was just sufficient the left hand side issue to be this straight line x equal to -2 is a vertical line. But I mean, either you go closer and closer to -2 from the right side, the same type of phenomena, the curve is getting larger and larger without any bound. So this is clearly a vertical asymptote. Can you show me what is the another vertical asymptote on this for this function? All right, yes, you might have noticed somewhere over here on this location when x is x equal to, let's say, 3, we can clearly see here even on this location, whenever we go closer and closer to 3 from the left hand side, the curve is just getting smaller and smaller. It's decreasing without bound, right? So that's why it's actually the line x equal to 3 is said to be vertical asymptote. So this is a nice example. You want to see some more example? Let me see if I have some over here. All right, let me first so this is the curve, the curve, the rational function y equal to 5x plus 2 divided by 6x square minus x minus 2. We can see the similar phenomena over here at x equal to -2, right? And then also at x equal to 2/3. Generally, to represent the vertical asymptote, we use the dash line. So this is the perfect image for that. This particular page, we'll try to learn how to determine the vertical asymptote of the rational function. We have already seen in the graph how to do that, right? But how to do it algebraically, let's try to discuss on that. Let's try to consider a rational function. Whenever we have a rational function, that means we have a polynomial on the numerator, a polynomial on the denominator. Let us say assume the polynomial on the numerator by n and the polynomial in the denominator by d. So how do you find the vertical asymptote for this rational function? What we do here is, first of all, we try to see if they have some real zeros in common. Okay, if they don't have any real zeros in common, you just have to do is look into the denominator and then see if the denominator is equal to 0 at some location. Whatever is the location corresponding to that location, whatever is the vertical line you have, that is said to be vertical asymptote. Okay, that's how we say if the numerator and denominator polynomial have no real zeros in common, then if you have a real number where the denominator is 0, then the line x equal to that real number is a vertical asymptote of the graph f. So you can see on this particular example, the denominator function is 0 at the denominator polynomial will be 0 at x equal to -2, right? So that's why we have seen even on the graph x equal to -2 is actually the vertical asymptote. If you have, let's say, the numerator and denominator have some like a common real zeros, that means wherever the denominator is 0, if the numerator is also 0 exactly at that location, just try to cancel out the common linear factors, whatever is that. I believe you can cancel out the common linear factor. That's why you are getting those real zeros. And then when you cancel out the common linear factor, then what you have to just do is, go to the case 1, because after you cancel out the common linear factors, then uh, there will be no real zero in common, and then you can immediately apply the case 1. All right, now let's try to see how to find the equation of any vertical asymptote. Find the equation of any vertical asymptote. And let me take one example. Let's say f of x is equal to x minus 3 over x plus 3. So how to find the equation of any vertical asymptote that may have for this rational function? As we have discussed earlier, to find the vertical asymptote of the rational function, first of all we can check if they have any real zero in common. We can see on this rational function the denominator polynomial has a linear factor, just the x plus 3, and the numerator is x minus 3. So that the denominator will be 0 at whenever x plus 3 is equal to 0. That means when x is equal to minus 3. But if you plug that number into the numerator, you can see that the numerator is actually not equal to 0. So in that case, they don't have any real 0 in common. So if that is the case, then we can clearly say that x equal to minus 3 is the vertical asymptote for this problem. Very easy, right, in this case. So let's try to see another example where we have f of x is equal to x square plus 1 divided by x square minus 1 times x square minus 9. And our goal is to find the vertical asymptote of this, again, this rational function. So how to find the rational function, how to find the vertical asymptote of these? Again, we begin from the denominator. You can see on the denominator we have x square minus 1 times x square minus 9 is equal, let's set it equal to 0 first. We want to see where the denominator is 0 first, right? And x square minus 1 has a factor x plus 1 times x minus 1, right? Similarly, x square minus 9 has x plus 3, x minus 3 are the linear factors. Set 8 equal to 0, and you can clearly see when x plus 1 is set it equal to 0, then we get x equal to minus 1 as a solution. From here we get x equal to 1 as a solution. From here, when x plus 3 equal to 0, we get x equal to minus 3 as a solution, and when x minus 3 equal to 0, x equal to 3 is the solution. So we have these four number where the denominator is 0, but if you plug all of these number in to the numerator, you can see that still the numerator is not 0, right? Negative 1 square is positive 1, so positive 1 plus 1 would be 2. 1, plug that in, you will not get 0. So in this case also the numerator and denominator does not have any real 0 in common. So that case we have x equal to minus 1, x equal to 1, x equal to minus 3, x equal to 3. All of these are vertical asymptote for this function, vertical asymptotes of the given function f of x. Alright, let's take one more example, and let's take function f of x is equal to x square minus x minus 6 divided by x square minus 3x minus 10. Alright, let's try to see the denominator function x square minus 3x minus 10. See if this is equal to 0 at some location. This is quadratic equation, so either you can use the quadratic formula or just factor it out up to the linear factor, right? So let me try to factor these. So I have x square, so x and x I can write down as a first term of this factor, and at the end I have -10, and on the middle I have -3. So try to think of two numbers whose product is -10, but when you combine you get -3. Can you think of that? Okay, so -5 and +2, right? So -5 times 2, if you multiply you get -10, but when we combine we get -3, right? So let's set this equal to 0. Then we have the linear factor. When you set x minus 5 equal to 0, we get 5x equal to 5 as a solution. When you set x plus 2 equal to 0, we get x minus 2 equal to 0, right? So that these are the two solutions. But let's try to see when you plug this number into the numerator and see if the numerator is 0. Alright, so I just want to try that. So let me plug 5 in. So I get 5 square minus 5 minus 6. So 5 square is 25, minus 5 is 20, 20. So this is not equal to 0 over there. But when I plug in -2, let's see. Square of -2 minus -2 minus 6. Square of -2 is 4, right? And so this is 4. Negative 2 will be +2 minus 6. Wow, so this is actually, then it's look like this is equal to 0. So when x equal to -2, the numerator is 0. That means they have actually 0 factor in common. Well, what is that one? So we know that if we factor the numerator and denominator, the denominator will be x minus 5, x plus 2, as we have done earlier. The numerator can be also factored, and we already see one of the factor is actually x plus 2. Or if you want, you can just factor out like normally. This is x, that is x, and at the end we have -6. Try to think of two numbers whose product is -6. When we combine, see if those number would get -1, and clearly you can see that that would be x minus 3, x plus 2. On that case, you can see they have the one linear factor in common. Let's cancel that out, and the remaining factors is x minus 3 over x minus 5. And you can see the denominator function will be 0 when x equal to 5, and now they don't have any real zeros is in common. So on that case, x equal to 5 is the vertical asymptote of this given function f of x.